Hey everyone, it's Miss Billman. This is the Unit 1, Lesson 11 homework. So, tell why the situation is a proportion or write the assumption that must be stated to make this problem a proportion problem. We're going to use a factor puzzle. You could see I kind of already wrote on this one, but that's okay. To make a pale blue paint, Erica mixes 6 cans of blue and 10 cans of white. She has 35 cans of white paint. How many cans of blue does she need to get the same pale blue? So I'm going to line this up with the 6 to 10, and under the 10 in the column will be the 35 because I'm solving for that magical number for blue. I end up getting 21 cans of blue, but I might have to make an assumption, right? So I could be thinking that if she duplicates this and makes an even larger portion, we have to assume that the same color is still possible. And I know from being able, I've mixed paint before, and sometimes if you make the batches bigger, it really doesn't come out with the same color. It's sometimes hard to get it. But we have to assume that the same combo, the same color combination, will have the same ratio. Friendly Florist sells bunches with 16 daisies and 9 roses. Aunt Lynn wants a large bunch in the same ratio. If she gets 40 daisies, how many roses will she get? So I label it D and R. Under the D I write 16, and under the R I write 6 because that's roses. So she has 40 daisies and she wants a large bunch. So she has 40 daisies. I put the 40 under the 16. Now I'm looking for that magic number that will go under the 6. So the greatest common factor between 16 and 6 is 2. 2 multiplied by 8 gives me 16. That's a column. And 2 multiplied by 3 gives me 6. 8 multiplied by 5 gives me 40, and 5 multiplied by 3 is 15. So total, if she had 40 daisies, she should have 15 roses. That factor puzzle is my friend. It is something I know, a strategy I can go to whenever I have a proportion problem. So the problem states that they are the same ratio. It identifies that. It even says it on there. So we're good to go. Number 3, Central School has 6 printers and 14 computers. If East School has 28 computers, how many printers does it have? Wow, okay. So I already know off the top of my head what kind of assumptions need to be made, but I need to solve it. So I label it as printers and computers. So they have 6 printers and 14 computers, so 6 and 14. And then the 28 goes under the 14. I know the greatest common factor between 6 and 14 is 2. 2 multiplied by 3 is 6. 2 multiplied by 2 multiplied by 7 gives me 14. And 7 multiplied by 4 is 28. So my magic number is 12 for 12 printers. Now the tricky part of this is that this took 2 different schools, Central School and East School, and it doesn't say anything about how there's a rule that every school has to have the same amount or the same ratio. That was never stated. Maybe you think back to other schools you were in. Did they all have the same amount of everything? Not exactly, right? So that's an assumption we have to make. This does not state that the schools have to share any kind of ratio or any kind of proportional number as far as printers and computers go. So we have to assume that in order to make this a proportion problem. But that's okay because we're mathematicians on a mission and we're flexible. The twins baked pancakes using 10 cups of mix and 15 eggs. Everyone wants more, but they only have 12 eggs left. Oof. So how much mix should they use? So I have the M and the E, the mix and the eggs. Under the M, I'm going to write 10, and under the E, I'll write 15. Now, I'm looking for the magic number in the mix, so under my E, I put the 12. The greatest common factor between 10 and 15 is 5, or I could say 2. I'm going to put 5, and 5 multiplied by 2 gives me 10. 5 multiplied by 3 gives me 12, or 15. 3 multiplied by 4 is 12. Bring that 4 across as a row, so my magic number is 8 cups. So if I had to have an assumption, I have to assume that the same ratio is